it's kind of interesting every now and then to realize that maybe at this crucial moment where you thought that you made such and such decision and you live with the consequences of this decision today, there's another scenario that something else happened. And it could be that across different universes, you are in a different situations than you are today.
To chyba papuga. Powiedziała salam alejkum, nie? Salam alejkum. I guess, there was no one particular, there was not one particular profession, but many of them. And you know how it is in your childhood as you progress to your adolescent years. You change your views and you change what you like. But I think if there was one underlying theme, that was a sense of exploration and discovery. So I always wanted to be either a pilot or an astronaut or perhaps a sailor. Obviously, when I say something that is not true, the bird will say "ee-oh." Well, as a child, I had a usual set of dreams, and which are mostly based on your curiosity to find how things are. So those urge and desire to explore all those exotic places. No, that's true what I said. So the first thing you want to do is to explain the essence of my discovery in a few words about quantum crypto. Another thing was about free will, and there was a third one about what? A multiverse. Okay, so we'll take them perhaps in 3 different shots. Okay, well, let's see how it goes. So at the risk of making a clown of myself, I think I can summarize it in a way that my good Italian friend would do that. And I think uno, information is physical, right? So information is physical. Due. Now, what is the second thing? Well, the second thing is that if you want to due, if it is physical, eavesdropping is measurement. So obviously, in order to eavesdrop, you have to measure. And tre, if you measure in quantum physics, you disturb. I'll do it again. say go, I go. You say go, okay, I go now. Well, is there such a thing like a perfect cipher? So this question, of course, look, I wouldn't be a scientist if I would tell you yes or no. As always, well, it depends. So the answer is, well, it depends. And of course, it depends what you mean by a perfect cipher. And we are getting close to it. I would say by traditional understanding of what a perfect cipher is, yes, there is a perfect cipher, but of course you have to make assumptions about, for example, about free will. Do we have free will? And it's actually quite crucial in our understanding of perfect security. You also have to make an assumption about the nature and how it works. You have to believe that the quantum physics is the best we have. In practice, though, it's a different story. So, you know, I keep telling that in theory there's no difference between theory and practice, but in practice there is. So it's right, so is there a perfect cipher, you ask me? Kind of. Well, people tried, right? The whole history of secure communication is dotted with brilliant ideas, fantastic ciphers, brilliant people, brilliant code makers. And sooner or later someone comes along and says, well, I know how to break it. So if there's any lesson from history, then the lesson is there's no such a thing like unbreakable ciphers. But if there's something that comes close, very, very close, you know, almost touches up on this unbreakable cipher. There's this one idea that is known as the one-time path. So take a simple example, okay, just a simple example. Say it is 0, 1, 1, 1, 0. So it's 0, 1, 1, 1, 0. Okay? Now, nobody knows about this sequence. You know it, I know it, and no one else. Now, you take this sequence with you, you travel far away. What was it that we agreed? Something walking inside me, I'm sorry. And I really don't know what is the best way to explain those things. You know, I can go on some very superficial level. As a working scientist, you always feel that it's not quite true what you are saying, it's just a half-true. So you create more sort of interesting vision of something rather than, and you don't put enough substance there. And maybe this is a problem. So are you asking me, can I summarize it in more succinct way so that if you were to tell the whole story to your grandma over dinner, you can just communicate this message in a very simple terms? Well, first you have to give your grandma a glass of wine. That's a good starting point. And then you say, well, number one, information, grandma, is physical. You know, it is physical. It is tangible. You encode information. There's always physics behind it. Number two, if it is physical and I want to listen, then I have to measure something because it's physical, right? So
I just have to do a measurement. I just take a meter and measure something. And then you say, Grandma, point 3, quantum physics, this weird, wacky theory about how nature works, tells you that if you measure, if you want to learn something about nature, you disturb it. So number 4, Grandma, if you disturb, you can be discovered. No worries, we are happy to have your beautiful dog on the camera, and you, of course. You know, I always feel it's a little bit silly when you ask people to do those walks. It's so artificial, isn't it? You have all those scientists who are not natural actors, and they just walk in all kind of different ways, you know, just you do this way. What is a philosophical walk? You just walk like this. You know, or maybe you just walk in some kind of light way. You pretend and, you know, full of agility, and you go like this. That's silly, right? That's not what you want. You want something that is smooth, steady, gives a sort of a sense of gravity to what I'm talking about. Well, let's see. Question: what makes science beautiful, even though it seems that all those things that we learn, we sooner or later will have to look at them again and learn more. No tak, bo w słońcu ta energia ucieka, także muszę mieć cień. What makes science so fascinating and so beautiful? Even though it seems like a transient knowledge, it's something that is not
definite truth. Well, it's just what makes journey beautiful, right? So you sometimes travel to a given destination, but you then realize that going there is part of the story and maybe more interesting, right? So that's I don't have any particular predilection for the ultimate truth. Really? You know, I'm not so much into talking about material things like aircrafts and the like, except that I like flying those. So, but what shall I tell you about my aircraft? I mean, it's gone. So you know, someone else crashed this aircraft, and it's not there anymore. Oh, but that you know, I'm not quite sure how my relation to my aircraft can tell you anything about me. Oh. Yeah, I guess so. You can say that the magic of flying, for example, or the magic of diving, but you know, if you take flying, the magic of flying is that... Muszę się zastanowić, jak to powiedzieć. Which what? Oh, which elementary particle I would like to be myself. I'm usually positive in life, so maybe proton, right? So I'm certainly not negative, so there wouldn't be electron. Neutron. Neutrino, perhaps? Even better, neutrino, yeah. Co to następne było? Free will. Well, you know, free will. At least for scientists, free will seems to be essential for understanding nature. Just think about it. How do we learn about nature? We probe nature. And we then want to surprise nature and see how nature is going to react to our choices. So we make random choices. You know, we do this and see how nature reacts. This and see how nature reacts. Imagine the opposite situation. There's no such a thing like free will, and everything is predetermined. So basically, you don't discover anything about nature, because whatever you do, it's already there. It's already written there. And the nature doesn't have to be surprised, it just reacts to some kind of a script that there is. So is there a script somewhere which tells us that the whole history, which tells basically the whole history of the universe, what's going to happen to you, what's going to happen to me, what's going to happen to your dog? Newton and classical laws of motion makes you more confident that there is a script. Simply because at the bottom of it, you know, everything is predetermined. You as long as you can know positions and speeds of all particles in the universe, you may not know, but suppose you do know, or there is an entity that knows, then everything in the future is clear. It's quite clear what's going to happen. And then comes quantum physics, and at this point, you may keep asking questions. Well, we see that in quantum physics, certain outcomes are inherently, or they look inherently unpredictable. But then again, you ask yourself, well, is it really true that they are inherently unpredictable, or they still may be part of the script? Perhaps I'm also part of the script, and my behavior is part of the script. So perhaps I'm also part of the script, and my behavior is part of the script. So moving from we have not resolved the big question, if there is a script or not. So it seems that internally there is no way to know if it is all predetermined or not. We could be part of predetermined and pre-programmed reality. However,
quantum physics does is that as long as someone gives you this ability to change something, just a word or a letter in the script, then you can change the whole script. You have a technique, you have abilities to do it. So this tiny little variation can be amplified to the point that you can have many scripts. All of them could be possible. Physicists walk. But there's a difference between theoretical physicists and experimental physicists. If you don't know the community, you cannot tell the difference. But if you really want to tell a theoretical physicist from experimental physicists, there's this unbearable lightness of being on the theory side. And you see a little bit more gravity on the experimental side. And that's what will tell you the difference. So you feel that, you know, experimental physicists usually tend to be closer to the earth, you know, down to the ground, and you feel it, that they just no nonsense like real people. And theoretical physicists just look up, right? So remember, experimentalists look down, but they always go like this. And theoretical physicists, they look up, they go like this. There is a difference. There is a significant difference. If there is such a thing like God, and if that God designed the whole world and gave us just a little bit of freedom to make choices, not much, just a little bit, then the rest is up on us, so that we can actually take this little bit of freedom and make it as much as we can. So if there's a little bit of randomness in the universe, inherent randomness, then we can use quantum physics to amplify this randomness and to have as much randomness as we choose to have. Yeah, then do particles have free will? Do we attribute too much to ourselves by saying, well, we do have free will and therefore we are responsible for things and so on and so forth? Maybe. I mean, there is of course this possibility, but personally I certainly feel that I do have free will and I exercise my freedom on a daily basis. Well, in English you have of course those phrases that you don't want to use, but you do, like you like, so, well. Those are those feeling words where I wouldn't like to use them, but I use them. I would say that I tend to use too many conditionals. Sometimes instead of I have to, I would like to say I want to. And instead of I can't, I would rather say I don't want to.
You also ask a question about the notion of and the concept of free will. Where does it come into cryptography? So it turns out that in order to establish a secret, the part of the protocol that I design, and my colleagues work on that and design even better protocols today, is that you have to make free choices, choices that are not predetermined by anyone. If it happens that you are controlled by someone, then it wouldn't work. So secrecy requires free will, and without free will there's no much point to have a secret communication anyway. Well, probably I made it more complicated, right? So
it's quite interesting that your delivery is really dependent on so many factors, right? So sometimes the first one is usually not so good, the second one maybe, the third one, and then it goes down, right? So more you repeat it, it's not necessarily getting any better. In fact, there's this optimum, I think 2 or 3.
Well, you know, free will, it really is about, will I do this or will I do this? And how do I know? Somehow I choose between 2 different options in life, and the free will means that you don't know, nobody knows. Sometimes I don't even know what I'm going to do. Now, free will is very important in cryptography for 2 reasons. One is it's just embedded in the protocol. That means that if I want to implement secure communication, I have to make free choices. Second, actually, if you come to think about it, right, it doesn't make sense to have privacy without free will. Privacy or secret information means something that allows you to act upon this. Having this information or not having can make a difference, right? Basically, in one word, multiverse is whatever can happen, happens. And multiverse.
yourself, I guess it may be common. People usually don't like themselves on the screen, but I develop a real dislike for myself, when I watch myself, and if it were sort of like another character, I wouldn't like that character. I feel I look silly, stupid, have nothing interesting to say.
I tend to say that multiverse is taking mathematics of quantum physics very seriously. If you see on your piece of paper, when you do all these calculations, that a given object can evolve into either this state or that state, it's not either or, but it's both. We write all those equations, we scribble those things to make predictions, but really we should take also very seriously what we see on that piece of paper, or if we do it on computer, in our computer. And what it tells us is that sometimes if there's a possibility for something to happen, it does happen. And there are two or many more coexisting realities. So me on the right side of the camera is one reality, and me on the left side of the camera is another reality. So there are two different states. In one universe, I do exist here, and in the other one, I'm on the right side of the camera and I exist in a parallel universe. The whole notion of multiverse is not immediately given to our experience. We still feel that even though random things happen in our life, we only follow one path. Experience is secondary. Your experience can be very misleading. You usually try to trust your reason, your explanation, your power of explanation first. We know that it is the Earth that moves around the sun, right? And that's the power of explanation, the best theory we have. Even though your experience is completely different, you think it is the sun that is moving there. But it isn't, that's only your perception. And to switch from this geocentric to heliocentric system requires a powerful explanation coming from physics, which goes against your experience. It's like a pilot that goes into those difficult meteorological conditions. So you're flying your aircraft, and then the mantra for all pilots with instrument rating is trust your instrument, trust your instruments, don't trust your judgment, don't trust your perception. Sometimes the horizon will be like this, and you think, oh, am I just banking this way or that way? That's not true, actually. Trust your instruments, fly the instruments. Well, the quantum physicist law, you have to pay attention to this because it's actually quite complicated. You have to just focus on my legs in this particular case, and you see how it goes. So a real quantum physicist, hardcore quantum physicist, would walk like this. You just put this like here, and then you move forward actually, but it requires a little bit of skill. So this way and this way. So that's a real quantum physicist. Non-Copenhagen, Copenhagen are just, those guys are, depends very much on interpretations, but the Copenhagens, they just go like this. It's nothing sophisticated about it. Old-fashioned guys. The real quantum physicists, especially in quantum information science, you really have to do this leg thing, honestly. And you cannot do it like sideways, that would be easy. That's cutting the corners. You really have to do it this way. You start with books like The Little Prince and other books by Saint-Exupéry, where you feel a bit of a magic of flying. It's not always like this. As a pilot, you have to struggle with all kind of weather, and it's a hard work sometimes to go from A and to B. But there are also those moments where the beauty of flight is so overwhelming. You develop this irrational link, and you want this aircraft to be part of you, really. Yeah, I think, old habits die hard. So there are still people who believe in all those other interpretations, but they will die eventually. So I think a quantum physics taken seriously with a multiverse approach will prevail. So I think the future is multiverse.
I think that it's kind of interesting every now and then to realize that maybe at this crucial moment where you thought that you made such and such decision and you live with the consequences of this decision today, there's another scenario that something else happened, and it could be that across different universes you are in a different situations than you are today. So it's, again, it depends very much on individuals. Some people may find it appealing or comforting, that it gives you a certain degree of comfort to realize that what happened is what happened, but what didn't happen perhaps happened as well. I don't know. Does it make sense? Maybe it doesn't make sense.
My current state of mind, well, it's always chaos, it's always been chaos. I may look calm and composed when you look at me, but there's always something going on there. I just don't know what it is. It's very difficult to provide a compelling explanation for things that are somehow on the fringe of our understanding, as the whole notion of multiple realities, for example. I'm always very skeptical about people who claim that they know the truth, that they stand up and pontificate. Quite often we have a patchwork of understanding. We have a little bit of understanding of A, a little bit of understanding of B, a little bit of understanding of C, and then if we try to make connections between A, B, and C, whatever A, B, and C might be, those things become more difficult. So the fact that you have a local explanation doesn't necessarily mean you have a good global explanation that would cover all the three. Do I think life in science is like a quantum walk? Well, this is a serious question, so let me just put it on. Yes. Yes. You want me to elaborate? You have this classical walk where you know where you're going, where you have a well-defined problem, and then you know that you're trying to solve it this or that way, and you use your mathematical tools. It has a bits and pieces of randomness to it, but it's more or less well-defined. So it's just at the stage where you have a well-defined problem, you know where you're going. That is good science, but it's not the most creative, it's not the most surprising kind of science. The most exciting part of science is where you don't really know where you're going. So you try to formulate a problem first. You're like a dog, you sniff around here and there, and it is a little bit like a random walk. So you walk in this direction and you think, oh, well, that's interesting, and there's something else. And then you have this feeling that maybe nature works like this, or maybe this mathematical concept is like this. And in this randomness, a set of random ideas and of sort of like a random walk, every now and then you step on something and then you just see, whoa, maybe I should stop and explore it a little bit. So that's as serious as I can go, I'm afraid. Well, your question is, to what extent prior knowledge shapes your perception of beauty? And you can see a beautiful sunset without knowing too much about optics and underlying physics of the sunset. But the more you know, I think it's not less beautiful, it's more beautiful, I would say. When you fly an aircraft, the more you know about the nature around you, it makes it even more beautiful. You respect nature and you become a more humble and perhaps better pilot this way. Knowing more is certainly something that not only keeps you safe, but also gives you a sense of, I don't know even how to describe this. There may be no good words to tell. I may be saying something trivial. Knowing more makes things more beautiful. That's true. In mathematics or even physics, theoretical physics, you make your discoveries pretty early in your life. And it's interesting to see how many of us try to pretend later on as we go through life that we are still doing great, that we are doing fantastic things. And maybe from a subjective point of view, that's the case. You have a feeling that you're still involved in research, you're still solving this and that, but somehow I feel that what is, at least in my case, objectively recognized as an important contribution to cryptography, that could be a highlight of my scientific career. But I don't care about it that much, because one thing that happens in your life, as you grow older, at some point you start caring less and less how people perceive you, what people think about you. Up to the age of 30, maybe 40, you might be obsessed by the perception of the world. You are very insecure. You want to prove yourself. You want to show to the world, look how wonderful mathematics I did. So look at this, a beautiful piece of work. Look at this paper, zillions of citations, right? And after some time you say, well, do I care so much about it? The challenge doesn't have to be anything big, right? For example, what I love doing, and this is probably a passion of my life, is this recreational mathematics, mathematical puzzles, little puzzles, and you are challenged to solve it and find some neat and nice solution. I don't know really whether I'm driven by meaningful, by a sense of purpose or big things. I think if I were to be really honest, it's a little bit of, at least in my case, you do what you think gives you some kind of a sense of satisfaction, and maybe that also creates a sense of fulfillment. But it is not that I'm driven by big ideas, obsession, and desires. I don't have a plan of the type. Find out about the nature of randomness. I wish sometimes I had. I wish I had this desire to go to the bottom of it, trying to understand. To some extent I do, but you know, if I'm distracted by something else, so be it. Perhaps something else is equally nice. So I guess I'm usually every now and then I have a path and I know where I want to go, but I don't mind to deviate from that path. It's sort of like a random walk through life, and I think that creates lots of nice surprises in life, which is important. Yeah, I guess I'm a bit of a private person, and it's just part of my personality. I'm quite happy with that. Oh, you mean how many? You're asking whether are things I'm not supposed to tell you because otherwise I would have to kill you? Oh, right. Well, many. Ooh. Depending in which universe, you know. If I were to be born in the 17th century and had a choice, then I think that I would dream about going to those Spice Islands to Southeast Asia. Yeah, I guess so. And then what? Then well, there's probably no coherent story to those counterfactuals. What would you do? If I had a chance to go and discover a new world, I think I would like to be someone like a charter surveyor, you know, someone who's going there, looking at the land, measuring the land, trying to put it on the map. That would be that would be something that I would enjoy doing. Mapping the world, yeah, that's. Sometimes I do have a feeling that I missed my train. Well, sometimes I do have a feeling that I somehow missed my train in life. That if I were to live in the 17th century, I would like to go for exploration's big way. I would like to sail the seas and see all those exotic lands of spices and the like. But I have to say that going inside the world of ideas and mathematical constructions can be satisfying, because when you do mathematics, when you do theoretical physics, you try to guess how things are, and I do believe that in mathematics we discover rather than invent. So somehow the mathematics is a shared experience, and we can communicate about the beauty of mathematical system. And once we do it, you have a feeling that we talk about something that have objective existence of its own. So it's like one of those Popperian world of ideas. You sail through the beautiful landscape of mathematics. Sounds poetic, right? But it is actually quite interesting and rewarding experience. On what occasion do I? Oh, on what occasion do I lie? Actually, I'm warming up, to this conversation. So I think I'll just maybe try again.
You say go, I go. You say go, okay, I go now.